Here's a question. It's a strange one. Is our universe a giant neural network? It sounds like something from a movie, or something you'd overhear in a coffee shop in California, and maybe that's all it is. A fun idea, a metaphor. But some people, including some serious physicists, are starting to think about it. They're looking at the way the universe is built. They're looking at the way neural networks work. And they're seeing similarities, strange similarities. The idea isn't that the universe is a computer, like in the Matrix. It's not about a simulation run by some other being. It's more fundamental. It's the idea that the very fabric of reality, the laws of physics themselves, might operate like a learning, evolving network. A system that processes information, a system that changes over time, a system that might be, for lack of a better word, learning. This is a deep dive. It gets weird, it gets philosophical, but it's worth thinking about. Because it changes how you see everything. It changes what a star is. It changes what you are. So let's just talk about it. Let's see where the idea comes from, what it means, and whether it's complete nonsense or a hint about the true nature of reality. First, we need to be clear about what a neural network is. The term gets thrown around a lot. We hear about it with AI, with self-driving cars, with apps that can write poems. But at its core, the idea is simple. It's inspired by the brain. Imagine a huge number of tiny, simple things. Let's call them nodes. In the brain, these are neurons. In an artificial neural network, they're just bits of code. These nodes are connected to each other, thousands, millions, billions of connections. A single node might be connected to a few of its neighbors, or to many. Each connection has a strength, a weight. Think of it like a volume knob. A connection with a high weight means the signal passing through is strong. A connection with a low weight means the signal is weak. A node gets signals from all the nodes connected to it. It adds them up. If the total signal is strong enough, it passes a certain threshold, the node fires. It sends its own signal out to the other nodes it's connected to. That's it. That's the basic mechanic. A network of simple, connected things passing signals back and forth according to the strength of their connections. It doesn't sound very smart. A single node is dumb. It just adds and fires. But when you have billions of them connected in the right way, something amazing happens. They can learn. How do they learn? By changing the connections. The network is shown some data. An image of a cat, for example. It makes a guess. Dog. That's wrong. So an algorithm goes back and tweaks all the little connection weights. It slightly strengthens the connections that might lead to the right answer, cat, and slightly weakens the ones that led to dog. Now show it another cat. It guesses again. Maybe this time it's a little closer. You do this millions of times with millions of pictures. Each time the network makes tiny adjustments to its internal connections. Over time, the network gets very good at recognizing cats. It has learned what catness is. Not because anyone programmed it with the rules of what a cat looks like, but because it slowly, gradually organized itself. It built an internal model of a cat, encoded in the strengths of those trillions of connections. The knowledge isn't in any one place. It's distributed across the entire network. So, a neural network is a system of simple connected parts. The connections have weights. And the system can change these weights based on experience. It can learn, it can self-organize, it can create complex behavior from simple rules. Now let's look at the universe. We tend to think of the universe as a bunch of stuff in an empty box. The stuff is particles, planets, stars. The box is space and time. And there are rules, the laws of physics, that tell the stuff how to move around in the box. Gravity pulls things together. Electromagnetism makes magnets stick and light travel. It's a mechanical view. A clockwork universe, as some used to say. But what if that's the wrong way to look at it? What if the universe isn't stuff in a box, but a network of events? What if everything is just a connection to everything else? Think about the largest scale we can see. The cosmic web. Galaxies aren't spread randomly through space. They form a gigantic, beautiful structure. Long filaments of galaxies and dark matter stretch for hundreds of millions of light years. They connect at dense hubs, superclusters of galaxies, and in between are vast, empty voids. You know, it looks like a network. It looks like a brain scan. The resemblance is striking. Of course, looking like something doesn't mean it is that thing, but it's a starting point. The galaxies are the nodes. Gravity is the connection. Now let's zoom in, way in, to the quantum level. This is where things get really weird and network-like. In quantum mechanics, you don't have little billiard balls bouncing around. You have particles that are defined by their relationships. An electron doesn't have a definite position until you interact with it. Its properties are a cloud of probabilities, and then there's quantum entanglement. You can have two particles linked together. No matter how far apart they are, if you measure a property of one, you instantly know the corresponding property of the other. One is spin up, the other is spin down. It's as if they are one system, one object, even if they're on opposite sides of the galaxy. The connection between them isn't through space as we know it, it's a direct link. It's a network connection that doesn't care about distance. The universe, at its most fundamental level, seems to be a system of interactions, of relationships. Nothing exists in isolation. Everything is defined by its connections to everything else. A particle is just a set of properties that describes how it interacts with other particles. Space and time themselves might not be a fundamental backdrop. They might emerge from the geometry of all these connections. The network itself might create what we experience as space. So, we have two systems. One is a neural network, a collection of nodes and weighted connections that learns by adjusting itself. The other is the universe, a collection of particles and galaxies, all connected by forces and quantum links that evolves over time. Let's put them side by side. The structure is the first parallel. In a neural net, you have nodes. In the universe, you have fundamental particles, or maybe even points in space-time. In a neural net, you have connections with different strengths. In the universe, you have the fundamental forces. And gravity is a kind of connection. Its strength depends on mass and distance. The strong nuclear force is another connection holding atomic nuclei together. The dynamics are the second parallel. A neural network processes information. Signals flow through it. The state of the network changes from one moment to the next based on the inputs and the connection strengths. The universe does the same thing. The state of the universe right now is the input. The laws of physics are the rules that determine the connections. And the state of the universe a moment from now is the output. The universe is constantly computing its own future. The flow of cause and effect is like the flow of information through the network. But the most important parallel, the one that makes this idea so compelling, is learning. Or, to use a more neutral word, evolution. A neural network starts out random and disorganized. Then, as it processes data, it becomes more structured. It develops patterns. It gets better at what it does. It self-organizes. The universe did the same thing. It started out in the Big Bang as a hot, simple, incredibly uniform soup of energy. Almost no structure. Over 13.8 billion years, it has cooled down and become incredibly complex. Gravity pulled matter together to form the first stars. Those stars forged heavier elements in their cores. They exploded, seeding space with the ingredients for new stars, for planets, and for us. This life emerged on at least one of these planets, and that life evolved, creating ever more complex forms. And consciousness arose. We are here thinking about the universe that created us. The universe has clearly gone from a state of low complexity to a state of high complexity. It has self-organized, it has developed structures and patterns that weren't there at the beginning. Is this a form of learning? This is where the idea gets really controversial. If the universe is learning, what is it learning? An AI learning to spot cats has a clear goal. It gets feedback. Right answer, wrong answer. What is the universe's goal? What is its feedback? Maybe the goal isn't something external. Maybe the network is just trying to find a stable configuration, or maybe it's trying to maximize complexity. Or maybe it's learning how to exist. The laws of physics themselves might not be fixed. They might be the learned parameters of the network, the weights. Think about the fine-tuning problem in physics. There are a handful of fundamental constants in nature: the strength of gravity, the speed of light, the charge of an electron. If you changed any of these numbers by just a tiny, tiny amount, the universe as we know it couldn't exist. Stars wouldn't form, carbon wouldn't be stable, life would be impossible. Why do these constants have the exact values they do? It seems like an incredible coincidence. One answer is the multiverse. There are an infinite number of universes, each with random constants, and we just happen to live in one of the lucky ones that works. But the neural network idea offers another possibility. Maybe the constants aren't random at all. Maybe they are the learned weights of the cosmic network. Maybe the universe in its earliest moments went through a rapid learning phase, trying out different values until it settled on a set of parameters that allowed for stable, complex structures to emerge. The fine-tuning isn't luck. It's the result of the universe training itself. A physicist named Vitaly von Churin at the University of Minnesota, Duluth, has published a paper on this. He takes the idea very seriously. He suggests that the universe is a neural network on a microscopic level. He argues that quantum mechanics, with its probabilities and weird connections, is what you would expect to see if you were looking at the behavior of a hidden neural network. And that general relativity, Einstein's theory of gravity, is what emerges when you look at the collective behavior of the whole network on a large scale. In his view, everything we see, particles, forces, space, time, is an emergent property of this underlying network. And the evolution of the universe is the process of this network learning. He even suggests that natural selection isn't just for biology. It might be a fundamental principle of physics. Systems that are more stable and can produce more complexity are selected for. The network reinforces the connections that lead to those outcomes. So if we take this seriously for a moment, what does it mean? What are the implications of living in a universe that is a giant neural network? For one thing, it changes what we are. If the universe is a thinking, learning system, then we aren't just accidents. We are part of that system. Our brains are neural networks. They are incredibly complex, information processing subsystems that have emerged within the larger cosmic network. We are, in a very real sense, the universe becoming aware of itself. Our thoughts, our discoveries, our art. This is the network generating new and complex patterns. We are not separate from the universe looking at it. We are the universe looking at itself. This could also reframe our understanding of consciousness. Where does consciousness come from? How can a lump of wet gray matter in our skulls produce the experience of being alive, of seeing the color red, of feeling love? It's one of the deepest mysteries in science. In the neural network model, consciousness might not be a special, weird thing that only happens in brains. It might be a fundamental property of information processing in a complex network. Maybe any system that reaches a certain level of interconnectedness and self-organization develops some form of awareness. Perhaps the universe itself has a kind of diffuse, distributed consciousness, and our own minds are just a focused, high-density expression of that. But we have to be careful here. This is where the idea can easily tip over into pure speculation and mysticism. There are a lot of problems with this theory, big problems. The first, as we mentioned, is the learning goal. What is the universe trying to achieve? Without a clear goal or a feedback mechanism, the analogy to a learning neural network starts to fall apart. You could say it's just evolving toward complexity, but why? Why would a system do that? It's a question without an answer. The second problem is falsifiability. A good scientific theory has to be testable. It has to make predictions that you can go out and check. If the predictions are wrong, the theory is wrong. How could we ever test the idea that the universe is a neural network? What experiment could we do that would prove it or disprove it? Right now, there isn't one. It's more of a philosophical framework than a scientific hypothesis. It's a different way of interpreting the physics we already know, rather than a way of discovering new physics. And third, there's the danger of the metaphor. Our brains are very good at seeing patterns. We look at the clouds and see faces. We look at the stars and see constellations of hunters and bears. We've just invented artificial neural networks. They are the most complex and interesting things we're building right now. So, of course, we start seeing them everywhere we look at the universe and say, that looks like a neural network. A century ago, the most complex and interesting technology was the clock. So people described the universe as a giant clockwork machine. Before that, it was a grand orchestra or the body of a god. We always use the most advanced technology of our time as a metaphor for reality. Maybe neural network is just the 21st century version of the clock. A useful analogy, maybe even a powerful one, but just an analogy nonetheless. So where does that leave us? Is the idea just a cool story, a piece of intellectual entertainment? Maybe. But it might be more than that. Even if the universe isn't literally a computer program running on some cosmic hard drive, the idea forces us to confront the nature of reality in a new way. It forces us to focus on information, not just matter and energy. Physicists like John Archibald Wheeler have been saying for decades that the universe is, at its heart, informational. He coined the phrase "it from bit." The idea is that every particle, every force field, every bit of physical reality derives its existence from bits, from information, from the answers to yes or no questions. If you take this idea seriously, then the universe is a kind of information processor, like in a computer. And a neural network is a very specific, very powerful kind of computer. This idea also connects to other fringe, but fascinating, ideas in physics, like the holographic principle. This theory suggests that all the information contained in a volume of space, like a room, or a planet, or the entire universe, can be described by the information on its boundary, on its two-dimensional surface. It's like a hologram. The 3D image is just an illusion projected from a 2D film. In this view, our three-dimensional reality might be an emergent property of information being processed on some distant, two-dimensional surface. This sounds a lot like a network where the connections create the illusion of space. Or consider simulation theory, the idea that we are living in a computer simulation. The neural network universe is a version of this, but without the simulator. The universe is simulating itself. It is its own computer. So, let's step back. We have the universe, we see structures that look like networks, the cosmic web, the interconnected world of quantum particles. We see a process of evolution. From a simple hot beginning to the complex, structured cosmos of today, life, consciousness. And we have neural networks. We see how simple, connected nodes can learn, how they can self-organize, how they can produce incredibly complex behavior from simple rules, how knowledge can be distributed across a system. The parallel is there, it's a compelling one. The structure is similar, the dynamics are similar. The evolution is similar, but the gaps are huge. We don't know what the universe would be learning. We don't know how to test the idea, and we don't know if we're just fooling ourselves with a fancy new metaphor. Maybe the truth is somewhere in the middle. Maybe the universe isn't a neural network in the same way that a MacBook is a computer. Maybe the mathematics that describe how neural networks learn and organize are just a subset of the deeper mathematics that describe how a complex system, any complex system, evolves. It's the universe, an ecosystem, a brain, a society. Perhaps they all follow a similar set of underlying principles. Principles of connection, feedback, and emergent complexity. By looking at the universe as if it were a neural network, we might learn something new. We might be forced to ask better questions. Instead of asking, what is the universe made of, we might ask, what is the universe computing? Instead of seeing the laws of physics as rigid, eternal rules, we might see them as the evolved, learned state of the system. This idea changes our place in the cosmos. In the old clockwork model, we are insignificant. We are a chemical scum on a small rock orbiting an average star in a forgotten corner of a mindless, mechanical universe. Our existence is a fluke, it has no meaning, but in the neural network model, we are not insignificant. We are a product of the network's evolution. We are one of the most complex, most interesting structures it has ever produced. Our brains, our minds, our consciousness, we are the universe's way of thinking. When we do science, when we discover a new law of physics, it is the network discovering its own rules. When we create art, it is the network exploring new patterns of beauty and meaning. It's a strange thought. It's a big one. It's probably not right in all the details. But it feels less empty than the old story. It gives us a connection to the whole show. We are not just spectators, we are part of the process, we are nodes in the network. And we are not just passing signals, we are generating them. In the end, we can't say for sure. Is the universe a giant neural network? The honest answer is we don't know. It's a radical idea at the very edge of science. But it's not a stupid one. It's a powerful lens through which to view reality. It provides a new language, a new set of tools for thinking about the deepest questions of cosmology and existence. And maybe that's enough. Maybe the point of asking a question like this isn't to get a final neat answer. Maybe the point is to shake up our old assumptions. To look at the familiar world around us, the stars, the trees, ourselves, and see it in a completely new way. As a single, vast, interconnected system, learning and evolving, slowly waking up.